The midpoint that is defined as is of a segment is divides the segment into two congruent parts. Basically, a segment you can say is like a chocolate bar, right? When you're sharing a chocolate bar with your friend, what you're gonna do? If you want to make it, you want to cut it in half, then you're gonna break it at the midpoint so you can share it with your friend, right? Um, Basically means divide the segment into two congruent parts. Example number 1 is Q is the midpoint of PR, right? So it's given, and it's going to ask you what's the value of PQ, QR, and PR. The diagram here provided is what relates to the statement above. Q is the midpoint of PR. PQ is equivalent to QR. You know, what facts are we given that we know that PQ is congruent to QR? You know that it's because of the definition of a midpoint. How do we know that that's the reason for our statement? Right? You can just say PQ is congruent to QR without providing a reason. Our reason is the definition of midpoint. And how do we know there's a midpoint? Because it is given. Q is the midpoint of PR. All the way to P to R, Q is the midpoint to make the half, the left side of its half, and the other right side is the other equal half, which is QR. Okay? So you know that PQ is going to QR. That means 12 is PQ, which equals to 12, will be equals to the value of QR, which also is to the value of 12. Next one, we didn't answer it yet. What is the value of PR? 12 plus 12, sorry. 12 plus 12 equals to the total value of P to R, which is 24. Okay, this is a statement here. You know that we're going to add the values of PQ and the value of QR, and we add them together to equal the value of PR, okay? Which is basically the same as saying, right? If we add the one half and the other half, it will equal the total segment, which is also known as the segment addition postulate, which we learned last week. Now here we add 12 plus 12. You can just leave PR as its own. And then you can answer 12 plus 12 is equals to 24. So the value of PR equals to 24. The next one is, the second example is M is the midpoint of AB. Find the value of AM and MB. So here you're given the whole segment, which is 26. So it's asking you for the value of AM, the value of MB. So what do you think the answer is gonna be? Just divide 26, which is the total, by 2, but you know that it's divided into two congruent parts, right? Congruent, you can just divide 26 divided by 2. You get the answer, which is AM is 13 and MB is also 13. Good job. Now we're gonna go move on to our last example. What do we see here geometrically? We don't just look straight away from the algebraic expressions given. Right away, look at geometric, right? Just pretend that the algebraic don't exist. Here you can see that there's a tick mark. PT has a tick mark, and TQ has a tick mark. So that tick mark emphasizes that PT, right? PT is congruent to PQ. That's sort of a statement I can actually write down, right? It's a true statement. PT is congruent to PQ. Is that a false statement? I don't know. I have to provide a reasoning. How do I know this is a true statement? How do I know PT is congruent to PQ? Use definition of a midpoint. Or you can use definition of a tick mark, whichever you want to use. Whichever you saw first, right? Definition of midpoint means that two segments are congruent, or they are cut into two separate, or they have the same measurement. tick mark emphasizes that they have the same measurement. PT is congruent to PQ. This is the first step you should always do, is write down the geometric statement. Don't solve right away, because that's a habit that you've learned through Algebra 1, I believe, right? Or the past. This is the time where we analyze, right? I think. And I like to do the equation line, just so you can tell what I'm organizing my work all over the place. Then I will substitute the value of PT, which is 5x plus 3. The value of TQ is 7x minus 9. Now, when you answer that, what was the first step you would do to solve that? Before you do this, always provide reasoning. The reason why I got this is because I used substitution. Once you substitution, then you can start simplifying each side of the equation. Right? Look at the left side. Can I simplify this expression? I simplify it because it's already simplified. Because I cannot combine 5x plus 3, because 5x is a variable and 3 is a constant. I'm going to go to the next expression. Right? 7x minus 9. Same reasoning here on the left expression. I cannot simplify this expression because I cannot combine 7x minus 9. 7x is a variable and 9 is a constant. Okay? So what am I going to do? I'm going to start working with both expressions. Okay, this is the time where you can work with both. Always take the idea of, can I simplify this expression? Can I simplify this expression? Once you're done simplifying both expressions, then you can start solving. Solving the equation is different, because solving the equation means I can start using the rules that I like to use, which is I want to combine the values of 7x and 5x. I don't know which side I want to do, but for me, I can do mental math, sort of. So I want to put the minus 5 on both sides. I'll explain later, but I'm going to show the work later on. Okay. The next n minus 5x is 2x. Drop down to negative 9, so you don't have to keep cluttering all your work. I know you can save space, but I rather make sense of the work and have save some space, right? The next one here, I know the likenesses are 3 and minus 9. I'm going to move minus 9 on the left side so I can combine the like terms or the constants. And so I can make the variable by itself. Plus 9 on both sides. I forgot to do something here. How do I get this equation again? I use the subtraction property of equality. I apologize for that. And here, minus 9 plus 9 is 0. Drop down to 2x here if you want, early. And 3 plus 9 is 12. And how do we get this final statement here? We got this final statement because we use the addition property of equality. Last step, don't forget that next to the value of the constant and the variable is always the multiplication sign. Okay. How do you cancel out multiplication? You reduce division. Divide through the same integer, and your final answer should be x plus 2 divided by 2 is 1. You have to put 1 because that's not necessary. 12 divided by 2 is 6. And we got our final answer for 6 because we used the division property of equality. Okay. So now x equals 6. Are we done? Is the question. You should always tell yourself no, because what's the question really asking us? We're trying to find the value of PT, TQ, and PQ, right? So how do we do that? I'm going to show you the long way first. PT has the equation of 5x plus 3. We can substitute the value of x, which is 6 plus 3. 5 times 6 is 30 plus 3, which is 33. I'm going to check the other answer. which is value of PQ. PQ is 7x minus 9. You can just automatically use a calculator and just input it. 7 times 6 is 42. Minus 9 is 33. Once again, how did I do this? I use a calculator, right? You don't have to always show me all your work, especially checking your work. That shouldn't be a big deal to you. It should be already innate in you to double check your work by substituting your final answer into the equation given that value, right? Here you know that PT is 33, PT is 33, and PQ is 33. So what is the value of PQ? PQ would be, you would add PT, which equals to 33, plus PQ, which is also 33, and it will give you equal to the whole segment, which is 33 plus 33 equals to 66. PQ equals 66. Okay? You guys have any questions about that one? Let's side note for that. Just in case students, when they want another example, how do you do this equation backwards, right? How do we do it? How do we just write this? 5x plus 3 equals 7x minus 9. Okay, you can still just do the same steps. Simplify, or again, simplify anymore. Simplify. So I'm going to solve it together, right? So this time I'm going to put minus 7x on both sides of the equation. Cancel it out. This will turn to a negative 2x. Drop down the plus 3 and drop down the minus 9. Once again, combine the license of the constants. Minus 3 on both sides. Positive 3, negative 3. That's a 0. Minus or negative 9 and negative 3. Combine that will be negative 12. And that'll be negative 2x. And the last step is 2. Once again, in between negative 2 and x is a multiplication symbol. Cancel out multiplication with the inverse, which is division. Divide by the same integer, which is negative 2. Whenever you're multiplying or dividing, you multiply or divide the same integer always. Now, negative 2 divided by negative 2 is positive 1. Negative 2 or negative 12 divided by negative 2 is, again, 6. I'm not going to be too technical in the rules. Again, you can use a calculator to help yourself out. But that's the most scientific calculator. Same answer. And that is it for the lesson. I'm just going to add one word. Hold on. Let me look for it. Next one I'm going to do is I'm going to write a synonym. Synonyms. Is that right? Synonym of a midpoint. Okay. We already know a midpoint divides two a segment into two different parts. We have another word that's a synonym for that, which is a segment bisector. Whenever you see the word segment, whenever you see the word bisect, it just means the same thing of a midpoint synonym. I'm not gonna over-explain that. Maybe we'll see that later on. But if you want an example, okay, basically, MD bisects segment. MD bisects segments AB. This is a small example. You don't have to know this. Well, you kind of do, but so here this is segments AB, and this has the value of. You guys see this here? sorry, value of 20. We have a segment that cuts in the middle, that segment MD. So if you know that segment MD is a segment bisector, segments bisector, then you know that this point here will be cut in half. This will be 10. This will equal to 10. Why? Because the whole segment is 20. MD is a segment bisector, cuts it in half. Same thing as a midpoint. We'll cut it in half. And that is it for the lesson. I don't want to put too much on the segment bisector because it will just confuse you more. If just know that it's a synonym to a midpoint. And that is it for the lesson. I'm going to stop recording.